to work properly, the armature air gap, that area between the flywheel and the armature itself, needs to be set between 6 and 10 thousandths of an inch. And so you have two legs on most of these armatures, one over here and one over here. We want to check to see that both of them are the same, and we want to also test to see what you have. If you get up over about 15 thousandths, you may not generate enough magnetism between the magnet on the flywheel and the armature to create that initial voltage that's going to be turned into high voltage up here in the wire. So the easiest way to do this is bring the flywheel up to where you've got a good flat surface to work with between the legs of your armature and your flywheel, and then pull out everything from about 2 to 15 on here on the feeler gauge, and then pick one and check to see if it fits. So on this side I put a 10 in here. It just fits. It's a little bit tight. And what we want to do is go down and find the one that just fits a little bit better. So, and those are a little fatter. That's in the wrong location. So we're going down to 8 thousandths. And 8 thousandths slides in with a little bit of pressure. So I've got 8 thousandths on that side. Come to the other side. 8 thousandths fits pretty easy. I'm going to go up to the 10 now. 10 fits pretty easy. I'm going to go to, this is in the wrong place, but this looks like about a 13. And 13 or 12 fits easy. Okay? And I'm going to continue up until I find it. You got about 18 on here, correct, when you did this? Yeah. And so I would say you've got, you know, 8 or 9 on this side. You've got about 18 on this side. So it was incorrectly set. Is that enough to cause this one not to spark? I'm not sure, but we're going to check it out and see. Normally you can test these by hand as well. And setting them, I'll go back through that when we put the engines together. But it's quite easy to take this off of the magnet, loosen these two little screws up with a nut driver, pull this back, snug them, lay in the feeler gauge. And the one I like to use for that, I've got this 1950s version of a old feeler gauge here, and it's got one broken piece. That's exactly what we want. Okay, so, and you can remember it because it's the one that's broken on the end. That's 8 thousandths. And so then what we'll do is we loosen this, pull it back, snug it, then we lay this in between on the magnet, and then loosening these screws, the magnet will pull the armature right down to it, and we snug in the screws, pull this out. Now we know we got 8 thousandths. It's a real simple process, but it is rather important. And I think, and you notice there's also a lot of grease and crud in here. It's quite possible that it's so dirty that could be one of the reasons too. So I may have you adjust this one and test it again just by spinning it over and checking to see if we can get a small spark out of it before we take it apart. Otherwise, when we put it back together, we need to put a different armature on. By the way, one other thing I want to point out here, on almost all of the varieties of armatures we work with on Briggs and Tecumseh, the rivets that hold it together are flat on one side, pointy on the other. Scientific as this is, the flats almost always face outward. If you flip the armature around, it will not work. So that's, you know, just one of the things to keep in the back of your head, and again, we'll talk about that when we put things back together. Next process that we want to demo today. The next two readings that we take are crankshaft thrust and wobble. The crankshaft thrust is how much space you have in and out. There's got to be some movement to this. See that crank moving back and forth? There has to be some, because as the engine heats up, steel expands. And if you don't have any thrust, it expands, and all of a sudden it gets tight in the crankcase and it won't turn. And we did have one of our bigger motors a couple years ago we put together, and didn't have quite enough thrust, and it run fine until it didn't run anymore because it's sealed, it's seized up. So we're going to take it apart and add in spacers to get that thrust back. Now, to do that, we've got well, this is a precision tool, but the next precision tool that we use, not a vice grip, although this is important, it's part of it, but is a dial indicator. And what we're going to do on here is use our dial indicator, which each of the dinky little marks on here is 1/1000th of an inch, okay? And we will be pushing on this and pulling on this, holding this completely straight and steady in order to determine how much thrust we have on the motor. Now, that's a little tricky to do. So we've got this little snake here that's kind of floppy and flippy and so on and so forth, and we've got a vice grip. Okay, first thing I'm going to do is try to lay this out and figure out where I can put this vice grip. And remember, vice grips, you just snug them up, and if they're too hard, loosen them up a little bit, but that's got to fit solid. Okay, I want as little S-curve or turn on my snake as possible. And notice when that's looser, that just flops all over. We're going to make that that stiffen up in just a little bit. So I want to determine where I want to be for this. What's my best angle? Probably about right here. That's going to be a fairly easy angle to hold. And so what I'm going to do is, yeah, if you can study the motor, that would be helpful. I'm going to turn this right on here. This collar is hex in nature, so if we have to snug it up with a wrench, we can. Most times, that'll hold in place just fine. Now the next process is, you see this little knurled nut up here? The looser I have, the floppier it gets. And there's also a little handle down here. That helps me adjust this just a little bit. And so the first thing I'm going to do is I'm going to take some of the flex out of that. Kind of like magic, isn't it? And then we need to put the dial indicator in the holder. And in order to do that, we just loosen up our knurled nut. And now you notice the dial indicator moves when this part moves, but this collar does not move. So I've got to fasten the non-movable collar into the sleeve. Loosen up a little more so I can get that in here, and we're going to set this like so. I'm going to tighten that collar up on there just to hold that in place. Now, I'm going to put it so that you see the dial moving on here. Okay, I'm going to place that so that the dial is flopping around. That's a scientific way to say it. It's got movement and it's touching. And I'm going to tighten this up by hand, but it's still not tight enough. Now I take my little tightener down here and I tighten that up. And now it sits solid. On a dial indicator, the outer rim turns, and if you look down in there, there's whole bunches of numbers. So I'm going to move this, and that's called a bezel. And by the way, this dial indicator has hit the ground a few times. It still works, but there's no plastic face on it anymore, so please be careful with this. I'm going to move that to 0. Okay? So I've got the dial on 0. Now I'm going to pull the crank all the way back and reset to 0. Alright? Now when I push it forward, notice how it went from 0 to what did it go to? 20. Pull it back. And I'm going to do this a few times because if this is not tight enough, it's going to give you odd readings. But I should be able to go 0 in, out as far as it goes, back as far as it goes. I do that a few times, and you can feel comfortable that you have 20 thousandths of an inch in movement, in the thrust of this. Now, you won't know whether that's acceptable or unacceptable at this point because you have to read the manual and find out. But that you need to note on your paper, what reading you got. Now the next thing is the crankshaft bent? It used to be we had very few bent crankshafts in here. We get quite a few of them now. So you'll be doing this on your own because I've shown you how to work this now, but I'm going to loosen this up. I'm going to loosen this collar. Whoa! That's how we drop it on. Did you get that on tape?
Yes, I did.
Yeah. Okay. That's how we wreck our dial indicators. And I'm now going to set this on the side. Now I have to caution you on this one a little bit. We got that snug back in there. Got to caution you on this one because your keyways are going to catch and want to turn this. So we can go from the edge of the keyway around to the other edge of the keyway and then back around to get our reading. But again, I've laid that on like so. I tighten it up on here and then I add that tightening right here to hold that in place. And by the way, this shaft's got to be cleaned. If you've got grease on it, it's going to push you off a couple thousand. So you've got some cleaning to do before that. But when you do this now, we rotate our crank and we reset at 0, which I think I was pretty close. Yeah, we'll just reset the bezel at 0, and then you're going to rotate your crank, and you're going to look at the variation. I'm out about 7 thousandths, but if I look at this and pull off a wad of grease, we're not clean enough to take this test yet. And I'm going to bring this around to just kind of feel where that is, so I don't run the thing down or I don't run the edge of my dial indicator down in that groove, but I go to there, and then I come back and I do the same thing, and I write down how much deflection I get from 0, either one way or another. If we have more than if this is clean and we have more than about 15 thousandths of an inch of deflection, our crank is bent too much to use. Even 15 thousandths will make a big difference. But we live with a little bit of bend on some of these cranks, but they should be pretty straight. So those are the things you're going to be doing. Now you have to redo these tests because obviously I didn't give you correct information here because you've got the shaft is dirty. But that's how it works. Are there any questions? Now I get also, and the last thing I want to mention here, I get also that the first time you use this, it's going to be like, well, what do I do now? Okay? Try with your partner to get this right on your own. When you have it put together and you're not sure, then come to me. Because if you bring me all 3 pieces and say, how do I do this? I will say, yes, there are such things as dumb questions. If you come and you have it together, but you maybe don't have something quite right, okay? Then you say, is this correct? Is this the correct way I should be doing this? Then I can say, yeah, I think we can work with that, or no, we got to change this. Okay, so that's the story. Those are the 3 tests you need to take.